Hello everybody. Now in this lesson we will revisit rational numbers and understand the decimal expansion of rational numbers. We all know what a rational number is. A rational number is a number that can be expressed in the form p over q, where p and q are integers and q not equal to 0. So any number that can be expressed in the form p over q, where p and q are integers and q not equal to 0, is a rational number. Let's look at some of the rational numbers. For example, 1 over 10 is a rational number. One over 4 is a rational number. What about 3 over 8? It is a rational number. What about 1 over 7? It is a rational number. And what about 1 over 3? It is a rational number. Now let us look at the decimal expansion of the same numbers. 1 over 10 in the decimal form can be written as 0.1. 1 over 4, the decimal form of this is 0.25. 3 over 8, the decimal form of this is 0.375. The decimal form of 1 over 7 is 0.14287. 14287. It repeats and it goes on. The decimal form of 1 over 3 is 0.333 and it goes on. Now if you look at the decimal expansions of these rational numbers, either the decimal expansions are terminating or the decimal expansion is non-terminating but repeating. If you observe 1 over 7, 0.142857, and again it repeats 142857. So the decimal expansion of a rational number will either be terminating decimal or a non-terminating decimal. But how do we determine whether a rational number's decimal expansion is terminating or not? Let us dig deeper. Let's consider few terminating decimals and see what conclusions we can come up to. For example, let's take the first one, 0.375. This can be written as a fraction 375 divided by 1000. And this can further be written as 375 divided by 10 to the power 3. Let's try over here, 0.875. It is 875 over 1000, which is 875 over 10 to the power 3. Let's consider the third one, 23.3408. It can be written as a fraction 233,408 divided by 1 followed by 4 zeros, which is 233,408 divided by 10 to the power 4. Now if you observe these, all the terminating decimals have a denominator which is a power of 10. So we can conclude that any decimal any rational number with a terminating decimal will definitely have its denominator as a power of 10. Now let's consider the same examples further. Let's consider these terminating decimals. Let's take the prime factorization of the numerator and the denominator for each one of them. The prime factors of 375 will be 3 times 5 to the power 3. And the prime factors of 10 to the power 3 are 2 to the power 3 times 5 to the power 3. If we cancel out the common factors, 5 to the power 3 and 5 to the power 3, we'll end up with 3 over 2 to the power 3. Let's go to the second one, 0.0875. It can be expressed as 875 over 10 to the power 4. The prime factorization of 875 will be 7 times 5 to the power 3 over 10 to the power 4. The prime factorization of that is 2 to the power 4 times 5 to the power 4. If you cancel out the common factors, 5 to the power 3 and 5 to the power 4, the common factors, you will end up with 7 over 2 to the power 4 times 5. And what about 233408? The prime factors of 233408 are 2 to the power 4 times 7 times 521 divided by 2 to the power 4 times 5 to the power 4. This is going to be 2 to the power 6, not 2 to the power 4. So after cancelling out the common factors, we will have 2 to the power 2 times 7 times 5 to 21 over 5 to the power 4. Now coming to the fourth example, 104 divided by 10 to the power 3. The prime factors of 104 are 13 times 2 to the power 3. And 10 to the power 3 is 2 to the power 3 times 5 to the power 3. Cancelling out the common factors, you will end up with 13 times 2 to the power 3, 13 times 13 divided by 5 to the power 3. So if you observe over here, any terminating decimal can be expressed as a fraction p over q, where the denominator q is either a power of 2 or only a power of 5 or the powers of both 2 and 5. Obviously this has to be the case because any fraction with a denominator of 10, the power of 10, will definitely be a terminating decimal. We can express this understanding in the form of a theorem. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form p over q, where p and q are co-primes, and the prime factorization of q is of the form 2 to the power n, 5 to the power m, where n, m are non-negative integers. So any decimal expansion whose decimal expansion is terminating will have the denominator as a prime factor, which can be expressed as a prime factorization of 2 to the power n, 5 to the power m. Let's work backwards now. Let's try to figure out what is the decimal expansion of 3 over 8. 3 over 8 is a rational number, and we can write 3 over 8 as 3 over 2 to the power 3. Now since the denominator is a prime factor of 2, Definitely from the previous example we know that the decimal expansion of this will be terminating. But how much is it going to be? So in order to understand that, 3 over 2 to the power 3, I have to make the denominator as a power of 10. In order to make the denominator as a power of 10, I can multiply and divide by 5 to the power 3. So that my denominator now becomes 10 to the power 3. 2 times 5, the whole thing to the power 3 is 10 to the power 3. And 3 times 5 to the power 3 is 375. So now it becomes easy for me to write this as a fraction. It is 0.375. So 3 over 8, the decimal expansion of that is 0.375. Let's take another example. Let's take 13 over 125. First, let's express this as prime factors. 13 over 125 can be written as 5 to the power 3. Since the denominator is a prime factor of 5, definitely this will have a decimal expansion that is terminating. But in order to find out what is the decimal, I need to make the denominator as a power of 10. 5 to the power 3 I already have, so I will multiply and divide by 2 to the power 3. So what happens now? 13 times 2 to the power 3 is 104. And 5 to the power 3 times 2 to the power 3 is 5 times 2, the whole thing to the power 3, which is 10 to the power 3. And that, the decimal expansion of that is 0.104. Let's try 7 over 80. 7 over 80. This can be written as 7 over the prime factorization of 80, 2 to the power 4 times 5. Now in order to make the denominator as a power of 10, I have to multiply and divide by 5 to the power 3 so that the denominator becomes 5 to the power 4, because we already have a 5 to the power 1 over here. So 7 times 5 to the power 3 is going to be 875. And the denominator now is going to be 2 to the power 4 times 5 to the power 4, which is 10 to the power 4. The decimal expansion of that will be 0.0875. So we can easily find out the decimal expansion of any rational number p over q which has a terminating decimal by expressing the denominator as a power of 10. Let's look at this rational number, 1 over 7. Will this have a terminating decimal or a non-terminating repeating decimal? How can we find out? Now look at the denominator. Is it in the form 2 to the power n times 5 to the power m? Is it a product of the prime factors 2 and 5? No. So since it is not a product of 2 or 5, definitely this decimal expansion will not have a terminating decimal. And if you do the decimal expansion of 1 over 7, you will find out that it is 0.142857, and it repeats 142857, and it goes on. So just by looking at the prime factors of the denominator, whether they are a product of 2 and 5, we can determine whether the fraction is going to give us a terminating decimal or a non-terminating decimal. Take for example 1 over 3. Just by looking at the fraction, are we going to get a terminating decimal or a non-terminating repeating decimal? This is not of the form 2 to the power n and 5 to the power m. So therefore, 1 over 3 will not give us a terminating decimal. And if you check it out, it's going to be 0.333 and so on. It's a non-terminating repeating decimal. So looking at the denominator, if they are of the form 2 to the power n times 5 to the power m, we can conclude whether the fraction is going to have a terminating decimal or a non-terminating repeating decimal. Let's try this problem. Without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So let's find out whether this will have a terminating decimal expansion or a non-terminating repeating decimal expansion. What are the prime factorizations of 3125? It is 5 to the power 5, and 13 is a prime number in itself. So is the denominator the prime factor of the power of 5 only? Yes. So this is going to have a terminating decimal, because we learned that if the denominator is of the form 2 to the power n or times 5 to the power m, the fraction is going to be a terminating decimal. Let's figure out whether 17 over 8 will be a terminating decimal or not. Now, what are the prime factors of 8? The prime factors of 8 are 2 to the power 3. This is now in the form only 2 to the power n times 5 to the power m, where this happens to be 1 because m is 0. So the denominator has only a prime factor of 2, the power of 2. Therefore, this also will be a terminating decimal. Let's try number 3. 64 divided by 455. Whether this will have a terminating decimal or not. What are the prime factors of 455? They are 5 times 7 times 13. Now this denominator has prime factors 7 and 13, which are other than 5 and 2. So therefore, this will have a non-terminating repeating decimal. What about number 4? 23 divided by 2 to the power 3, 5 to the power 2. Since the denominator has only prime factors of 2 and 5, so this will have a terminating decimal. Looking at problem number 5, can you guess what is it going to be, terminating decimal or a non-terminating repeating decimal? Since the denominator has prime factor of 7, which is other than 2 and 5, it is going to be a non-terminating repeating decimal. Let us find the decimal expansion of 13 over 3125. The first step will be to figure out what are the prime factorization of 3125. So 13 over the prime factorization of 3125 is 5 to the power 5. Now if I want a terminating decimal, I have to make the denominator as a power of 10. So I'm going to multiply and divide by 2 to the power 5. so that the denominator becomes 10 to the power 5, and 13 times 2 to the power 5 is 416. Now I can easily express this in the decimal form as 0.00416. Let us express this as a decimal, a terminating decimal. So in order to do that, I have to make the denominator as a power of 10. Now in this case, it's going to be 10 to the power 3. How do I do that? I multiply and divide by 5 to the power 1, because 5 to the power 2 is already present. So now my fraction is going to be 23 times 5, which is 115 over 10 to the power 3. And that is going to be 0.115. Let's try this. 17 over 8. Express this as a terminating decimal. The prime factorization of 8 is 2 to the power 3 and 17 as it is. Now I need to make the denominator as a power of 10. In order to do that, I multiply and divide by 5 to the power 3, numerator and denominator. So now the denominator is 10 to the power 3, and 17 times 5 to the power 3 is 2125. So now it can easily be expressed in decimal as 2.125. I hope you have understood the explanation of this lesson, and please feel free to share this video with other students and subscribe to my channel. Thank you very much.